and we will send you the link via email during the next days. On the right-hand side of the presentation, you now see a Q&A window. Please make use of the window, type your question in the text field on the bottom. Only myself can see the questions, and I will read your question to our presenter later on in the Q&A session. Today's speaker is Dr. Lutz Werner. He's a product consultant here at Multichannel Systems. He earned his PhD in physics in Kassel and joined our company about 5 years ago. Today, he will give a presentation of about 30 minutes, and afterwards, he's available for the Q&A session, as mentioned before. So, I'll hand over to Lutz, and please enjoy our first webinar.
Thank you, Carla, and thank you too for attending today's webinar. I would like to welcome you all in my name and the name of Multichannel Systems to today's webinar for the introduction of the MEA2100 system. First, I would like to give you a very brief overview what you can expect from today's webinar. For those who have never heard of the microelectrode array technique, I would like to have a very short introduction into the recording principle. Afterwards, I will get a very brief overview about the microelectrode arrays. Afterwards, I will present the MEA2100 system, its components, and I will try to spice it up in between with some application examples. Last but not least, I would like to go into our software, which we provide for our systems. So the recording principle, what you see here on that slide are 4 different ways to record from electric active cells. Starting from the top, you will see patch clamp recordings, transmembrane recordings. If you go a little bit away from the cell, you have extracellular recordings, action potentials, but you can go in addition to intracellular to record transmembrane potential. Our approach is a little bit differently. You will see at the green arrow in that brownish color the microelectrode itself, which is placed beneath the cell, and you can record extracellular field potentials. In black, it is labeled the electrode track, which is going outside towards the connection unit. So from the recording principle, again, if you check for the intracellular recording, which is displayed on the left, and you go outside with the recording pipette, you will get an extracellular recording, which is roughly the first derivative of the intracellular recording. You will see the dimensions that you will come from a millivolt range towards microvolt range, which is demanding on the electronics, and therefore you need to have a very reliable and stable system. But if you go for a microelectrode array recording, you will have a composite signal, and the signal amplitude depends on the distance towards that electrode. If you compare a little bit intracellular and extracellular multi-electrode array recordings, you have advantages and disadvantages for both recordings. Of course, what you can do with intracellular recordings, you have the possibility to measure single ion channels. And for sure, you have the superior quality of the electrophysiological recording. Wherever if you go intracellular, you do irreversible damage towards your cell, and you have a washout of the intracellular compartments. And I would like to point out, I have deep respect for all people who are available to do intracellular recordings. You need considerable skill for quick and precise micromanipulation, and to have a stable and reliable recording condition, it's extremely difficult. If you go for high spatial resolution and a non-invasive approach, you have the microelectrode array recording. Long-term studies are possible, and it is quite easy to get network information as well as really long-term recordings, which can be over days, weeks, months, even years. Last but not least, it is to be pointed out, as on the slide before, that it is a composite signal, and the signal amplitude depends on the distance towards the electrode. But here's one thing I would like to point out too. The methods are complementary. So you can combine intracellular recordings, you can combine imaging together with MEA recordings. The next slide is presenting some examples of our different available microelectrode arrays. Multi-channel Systems is proud to present the widest range of commercially available electrode grid layouts. To the top left, you have an overview how it looks like from above. You have the contact pads to the side, and you have a compartment where your cell or your slice is placed with an electrode grid. If you look into the electrode itself, now displayed with a green arrow, you see in standard 8x8 grid with the corners cut out. The microelectrode arrays are available in many different shapes, rectangular, you have hexadimensional ones, but furthermore you have perforated MEAs, which are displayed now with a green arrow. These are special designed for slice recordings, and you have three-dimensional microelectrode arrays too, in that case displayed here now with a green arrow, cone-shaped ones. The material we are using are titanium nitride for the electrodes and indium tin oxide, which gives a very good signal-to-noise ratio. It is a very stable and robust material, and the safety charge injection limits are quite high so that you can easily record and stimulate at the same time. Last but not least, we have developed in the last years P.CNT2 for very low impedance value microelectrode arrays too. Last but not least, in the lower two pictures you see custom-made microelectrode arrays. There are many labs in the world producing their own microelectrode arrays. To the left, there's on mushroom-shaped electrode. Cells has been cultured on top of these. It's from a group from Israel. To the right, there's another example of custom-made electrodes from Giuliano and Martinoia in pyramid-shaped ones. Now, if we come to the MEA2100 system, it is consisting of three components. The first component we already explained, it is the MEA. And if we look from the signal pathway, from the signal source towards data storage and analysis, you have first of all always the electrode, in that case the microelectrode array. The next part is that you have preamplifiers, filter amplifier, and the data acquisition, and possible electrical stimulation. All these components are within the head stage of the MEA2100 system. Last but not least, as we try to have the head stage as compact as possible and to be usable with inverted or upright microscopes, we have put additional input and output ports as well as the connection towards the computer into the interface board, which is displayed at the left. I would like to introduce you now, first of all, with the MEA2100 interface board. The interface board contains 16 TTL in and output ports as well as 8 additional analog input ports. As mentioned before, you have the possibility to have complementary methods put together in one experimental setup. If you would like to input additional information, for example from patch clamp, into the MEA recordings, you have the analog input ports to record at the same time. An important point inside the interface board is the digital signal processor which can be used for real-time feedback, which I will explain in a second. And last but not least, you will see at the entrance of the interface board, now highlighted with a green arrow again, that you have the possibility to hook up two MEA2100 head stages, in that case increasing your throughput very easily. So, as promised, I would like to get a first glimpse into the real-time detection and feedback. With the digital signal processor integrated into the interface board, you have the possibility to download special settings for spike detection or hardware filtering onto the interface board. And if you start the recording from your cells, you immediately can distinguish between different patterns of spikes. You can see what is going on, and if you have programmed an output for stimulus output, it is done in less than 1 millisecond, as it is bypassing Microsoft Windows and sending out a stimulus as it is integrated into the head stage as possible. The digital signal processor is pre-programmed by multi-channel systems, whereas you can program it freely too if you have the tools available. So the MEA2100 head stage, we have different ones available. Before we go into the details of the different head stages, there's again some points I would like to discuss. First, the MEA2100 head stages contain, all of them, a 3-channel stimulus generator. They can freely choose between voltage or current stimulation. You switch via the software and you decide via software which electrode should be recording and or stimulating. All head stages have a 24-bit resolution and adjustable gain and bandwidth. Again, software decided. Last but not least, Planck circuit for stimulus artifact suppression is integrated into our head stages. So the first system I would like to show you here is the MEA2100-32 system. It's a specially designed system for slice recordings. It is only to be used with perforated MEAs. And to the right, you see 4 different layouts. For those who are experienced in hippocampal slice recording, they will immediately see some shapes they recognize. Those 4 layouts are to be used with the head stage. The small violet dots are the recording electrodes, whereas the bigger violet dots are the stimulating electrodes. So in the system itself, as said before, you have the integrated electrical stimulator for voltage or current stimulation, and you have integrated perfusion and suction as you use perforated microelectrodes with them. So you have a small suction from below, putting the slice towards the electrode surface. Here is one application example how it looks like if you have a hippocampal slice on top of a 32-channel recording system. The slice you will see here has a standard thickness about 300 to 400 micrometer, but you see that the middle part where the suction occurs is getting transparent as it is sucked towards the electrode surface, and you have the possibility to even see through the slice as it is getting thinner through to the suction. One very easy application which can be done with that system is, of course, LTP induction. What is displayed here in the picture is a 60-channel microelectrode array. You will have a slice grid on top. So what you see then in the red circles are the stimulation electrodes, the control pathway and the potentiated pathway, and in the middle you see the recording electrode. It's not only that you record from the electrode which is highlighted in green. Of course, it is very easy to change to different electrodes to go into a different region of the hippocampal slice. If we look into the results of that experiment, you see in the upper graph with A the relative EPSP slope. with the different stimulation pathways. First, in red, you see the potentiated pathway. In blue, you see the control pathway. And if you check to the right, you see again in the black line, you see the recordings 15 minutes before stimulation occurred. And in that grayish color, you see it roughly 4 hours after stimulation. And you see that learning effect which occurred due to the potentiated pathway. In the lower pictures, you see the same for the pop spike amplitude. Again, the amplitude displayed over time. So the next system I would like to show you here is the MEA2100-60 system, which means that the system is equipped with a connector for 60 channels, again integrated stimulator, and from below you have a heating plate to keep your culture or your cell on temperature. The system can be used with cell cultures as well as slice recordings. And it is nice to mention that you can change the system, that it can be used with perforated MEAs in less than 5 minutes. To be honest, well, I can do it within 5 minutes. But what is nice to know too is that you can upgrade your system very easily to 120 channels later on, as the electronic part is already equipped for 120 channels. A typical experiment which has been done in the past are organotypic cultures. What you see here is the display of a slice with the entorhinal cortex and the dentate gyrus, and how it looks like on top of the MEA recordings. So the idea of the experiment, which I'm going to show you here, is what happens over time if you stimulate in the EC. Do you see an answer in the DG part, and how does it look like vice versa? So on the star displayed on the electrode here, this were the stimulation electrodes, whereas the circle, the red circle, and to the right then displaying the results on these electrodes. You see, if you stimulate on the EC part, you immediately see, as well in EC as in DG, you see the stimulus pulse occurring, that sharp peak. An answer immediately occurs after stimulation in the entorhinal cortex, whereas a small delayed answer you will see in the dentate gyrus. If you stimulate vice versa, which is displayed on the right, you see on both parts the stimulation pulse, whereas there is no answer, as there is no connection inside the EC. So the recordings showed that after 2 days in culture, which is displayed on the right graph, you will see a connection starting between EC and DG, and after roughly 7 days you have a connection or no connection at all. The results showed too that roughly 77% were unidirectional connections, 17% were bidirectional connections, and only 6% showed no connection at all inside these tests. All right, next we are showing the MEA2100-120 system, meaning that you have 120 channels for recording. As before, you have the integrated stimulator, you have the integrated heating, and if you check for the system layout, it is nearly looking exactly the same from the outside dimension as before. The only part which is different is the connecting unit. Again, you can use the system for cell culture as well as slice recordings, and again, you can change the system very easily, that you can use it with perforated MEAs. We would like to show you next a Jovi part of the Jovi video, which has been done in the group of Paris. They recorded from human brain tissue, and we show you for a very short time the results of these recordings.
This is a representative trace of human cortical slice activity recorded by an MEA electrode. In normal ACSF, it is possible to observe interictal-like spontaneous activity. 15 minutes after the perfusion with magnesium-free 6 millimolar potassium ACSF, the first seizure appears and is followed by other events at 2 to 3 minute intervals. The blue trace illustrates the activity zoomed in. This panel shows the data high-pass filtered at 250 Hz, which reveals multi-unit activity when zoomed in on. Here is a representative recording of a seizure from all MEA electrodes in magnesium-free 6 millimolar potassium ACSF. Each square represents an electrode of 12 by 12 MEA array and shows an 80-second time window. The dotted line indicates the position of the cortical surface relative to the MEA array.
All right, so that was a short video, what you can see in the Jovi journal with our systems. You can find the download link towards that video on our website too, if you check for application services. So, last but not least, there are some things I would like to mention with the MEA2100 too. It is not only possible to have a 120 channel head stage, but what is displayed here are the different options of the head stages which are available. And to have a medium throughput, you can easily upgrade your system towards a double head stage, that you have 2 MEA recordings done at once. As each well can be stimulated independently, you have, to be honest, 6 channel stimulator inside each head stage, so that you have for each well 3 channels independently working. And if you go for higher throughput, you can have 6 well MEAs equipped with the head stage, giving you on a very small footprint a 24 well recording system. For medium throughput, there is often the question about cardiac applications. Here are some applications named and displayed. To the left, you will see a heart slice placed on top of a microelectrode array, and to the right, you see the field potentials displayed over time for QT analysis with E4031 nanomolar concentrations. And what you can see very easily is that the QT interval is prolonged if you increase your nanomolar concentration of the E4031. So there are many different easy assays what you can do with the MEA2100, and keeping in mind the possibility to increase the throughput with 6 well MEAs or a double head stage or a quadruple head stage. In that case, you immediately have a very nice medium throughput system, which is very powerful. If we check for cardiac applications too, what you can do too is excitation mapping and conduction velocity. Here displayed are cardiomyocytes. You will see that the pacemaker on the what is displayed here is roughly on electrode 87. We are labeling our electrodes row and column. So here to the lower right, you see that it is early displaying the sharp QRS pulse, and the signal is spreading from the lower right corner to the upper left corner at approximately 0.14 meters per second. And it is possible, therefore, to study gap junctions, re-entries, and cycling excitations. Again, we would like to show you here, if you go for conduction velocity and excitation mapping, what you can do too with in that case, a very small different software from us, Cardio 2D. There will be a special webinar on that, how it looks like. All right, the video has some problems occurring. No, here it is. It needed to upload. And what you saw here is in false color display, the starting point of the excitation of the cardiomyocytes, and here on the second video, how it is switching from the lower left to the upper left, the excitation pattern going from one corner towards the other over the cardiomyocytes. As said before, there are going to be special webinars on that software too. Therefore, please check out our website for that. All right. So the next part we're going into is stem cells application. If you check and if you screen our publication website, a lot has been already done with the MEA system, be it from human, mouse, or rhesus monkey, be it embryonic stem cells, adult stem cells, or iPS cells stemming from keratinocytes. It doesn't matter if you differentiate them into cardiomyocytes or neurons, they can be measured with the MEA system. So if you are unsecure if it can be done or not, contact us or screen our website. I hope I had the chance to show you that there are many different applications which can be done with the MEA2100 system. Neuronal cell cultures, acute slices, OTCs, whereas cardiac applications with cardiomyocytes, whole heart preparations can be done, stem cells, retina preparations I haven't shown today, but even intestine and plant roots has been measured already with that system. And whatever you come up with, if you feel unsecure, please contact us. Now for the last part of the presentation, I would like to go into the software. It is company philosophy that with the system you will get a general recording software for free, and it is included in every system and you have free unlimited upgrades. It is highly flexible and you can do already a lot of online and offline analysis with that software. As the software is now over 15 years old, we decided in the last years to come up with a little bit more modern design software, which is called multi-channel suite. These parts of the multi-channel suite I would like to show you in a second, but I would like to mention too the specialized software which we provide for special solutions, LTP Director and Cardio 2D. And additional software, again free of charge, is available. Examples are the temperature control, TCX control, or the data tool, which transfer the data into different data formats. The multi-channel suite, which is going to be released very soon on our webpage. We distinguish between three different pillars. The first pillar is the multi-channel experimenter. It is used for online recording, and at the moment it is only supporting the hardware for the MEA2100 system and our wireless recording systems. Each instance of the software can be opened for each connected data acquisition and for each individual MEA inside the MEA2100 system. So if you come up with a quadruple system, you can have 4 individual recording settings in multi-channel experimenter. It's a very simple drag and drop interface, and what is good to mention too, that there are custom plugins possible inside the multi-channel suite. If you go for offline analysis, you will have the multi-channel analyzer. It supports the files generated with a multi-channel experimenter. If you check later on in our webinars for wireless recording systems or in vivo recordings, it is equipped with a supports the synchronization of video input, and you can have event-based navigation inside the multi-channel analyzer. So for example, if you have drug application and you want to see what happens immediately after drug application, you can easily jump towards different points. Again, it's a simple drag and drop interface, and here custom plugins are possible too. Last but not least, you will have the multi-channel data manager. As you would like to analyze your recordings in different programs, we have a data manager where you can export your data to different file formats. For example, if you would like to analyze within MATLAB, you have the HDF5 file format, which can be read by MATLAB or Python. We can convert our data into the next format for Neural Explorer or into the Spike2 format. A data compression is immediately included in that data manager. So I would like to thank you for attending our today's webinar. There are already some questions occurring, and I will pass over to Carla to start the Q&A session. All right. Thanks again on behalf of Multi-Channel Systems and ourselves for the questions and your time already.
Thank you, Lutz, for this presentation. We had some questions about the reusability of the MEAs. Can they be cleaned and reused? Yes, the MEA chips can be cleaned. Different methods we have for different for different applications, different suggestions what you can do. If you check on our website, we have an MEA manual where you can read the cleaning procedures. Depending if you use slices, you don't need to have a pre-culturing, so cleaning with alcohol is very easy. But if you have a pre-culturing, you can use, for example, Turkosine, which is an enzyme cocktail, which you can then clean the cells. Autoclavation is possible for the MEA chips, and as long as you don't try to clean them manually or with ultrasonic sound, they last a long time. Rough estimation is 50-60 times. Thank you. All right. Another question was about the stimulation. If it is possible to stimulate via 3 electrodes simultaneously, or well, yes, on more electrodes simultaneously. Yes, it is possible. You can choose for all electrodes or only one electrode to be recording and or stimulating. So 3 electrodes simultaneously is of course possible. Sometimes needed if you need to put a lot of voltage into your system to stimulate your cells, for example. Yes. Another question just coming in was how many electrodes does the 6-well chip have per well? It's a 3 times 3 per well. Yeah. So 9 wells. Yes. 9 electrodes. 9 electrodes per well. So in total, you end up with yes the 60 channels yes. The system can support. Not complete, but yeah. 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 All right. Yeah. Then there were some questions about the limitations of stimulation. The limitations you will have are depending on the electrode material and diameter, as you have safe charge injection limits. If you stimulate with a too high current or voltage, you can damage your MEA permanently. So it is advised to check for our safety charge injection limits, which are displayed in the MEA manual, which I mentioned before. So yes, there are limitations, but normally, depending what you would like to stimulate, up to 3 volt, 2 to 3 volt is possible with a 30 micrometer electrode with titanium nitride, for example. If not, please contact us if you have special questions about your layout. Wonderful. Thank you, Lutz. I think all questions have been answered. If you have more questions, please feel free to type them.
Some questions we are seeing here, they will need to check a little bit into the details, but we will definitely get an answer to your question. Please wait for 1, 2, 3 days until we send out and contact you directly to that. But thanks to you all for your questions. There have been still only a few not answered, but there are some which we need to look a little bit into it too.
We will stay online for about 5 more minutes. So if thinking about it, some more questions occur to you, please feel free to type them. As I already said, we recorded this webinar, so you will get the link during the next days. And I also wanted to point out that we're only started holding webinars, and next week we will have one for accessories to upgrade your MEA system. So if you're already using a system, that might be an interesting webinar for you to join. We will also talk more about the different MEA layouts during that webinar. And we just developed a multi-well system for up to 96 wells. So if you're planning to go into higher throughput, this might also be a webinar that's interesting for you. I think it's scheduled for early May. And as always, if you have any question, you find our phone number and email address below. Please don't hesitate to contact us anytime. Thanks again for joining us today, for your time and patience. And I hope to see you soon during the next webinars. Thank you. Bye-bye.